Okay, so good morning, everyone. How are you today? Is your mood quite terrific or only okay? Stressed. So, as you of course are aware, next week you have your final exam. It's in the syllabus. Thursday, yes, Thursday.
Is it the same?
What do you mean this isn't the same thing?
Some classes are
Yeah. So you get like a 2-hour block of time. All classes, regardless of how often they meet a week, get a 2-hour block of time to do their final exam. Which means you can't use the same final exam schedule as you do there because, class that would meet every hour would immediately run into the next class when you have a 2-hour block of time. So we use an alternate schedule during finals week, which is why my office hour schedule doesn't apply anymore because everything has changed. And I'll be posting an alternative one office hour schedule tomorrow. In all likelihood, yeah, probably today or tomorrow. I haven't really figured it out yet. CJ, I got this for you. Good catch. Wow, one-handed. So that's what's going on. So that's why I include in the syllabus when your final exams. And yeah, Thursday. And I have them back to back. So what of course we're going to do is do our review session. This is your time. Whatever you want to talk about, we can talk about. And if you don't have any questions, then I'll have questions for you. So, does anyone have anything they wish to discuss? What was that? Last night's homework. Okay. What about last night's homework?
questioning.
So this is not the first time we've got this question for 12, right?
Yes.
Because the sample size is smaller, as we discussed, with a sample size so much smaller than the population, you can use binomial rather than hypergeometric. You use binomial instead of hypergeometric. That's what's going on. And you can see that now if you check the answer key.
So there was one question, it was number 5, it was like 250 and then 230, I remember that word, it was like...
I can't really do much. I only know question 8 off my head because I've been asked about that much.
But if it says like, for example, less than 250, would you add one? Would you say like 250?
Well, if it's less than 250, and I don't remember exactly the question you're talking about, but if this is 250 or less, so if you want to see less than 250, you would have to do 249 or less, and this is 250. Because since you can't go 249.5 or 249, there's nothing in between here. So that means less than 250 would be 249 or fewer.
So it's just
Yeah, maybe. I have to see the exact question. And that, thank you. And that is, let's see, I have to see the whole thing. More than 250 people will walk into your electronics store. How likely is it that more than 250 people? So, if you put in a cumulative function at 250 or fewer, you found the probability 250 or fewer have gone in. But you don't want 250 or fewer, you want more than 250. So in other words, you want 251 or more, right? Which means you would take 1 minus this. Right, and that would give you everything else. And you can look at the answer keys too for these. Yeah?
For determining a binomial probability, one of the questions was, women applicants. Okay, and the first one was a hypergeometric formula
with the cycle.
Yeah,
Because it was, so the population that is chosen is less than 5%?
yeah, the sample is less than 5% of the population of the patient could choose, then you use binomial. Because by that point, like, the probability really isn't changing from the event to event, or from trial to trial. Yeah. Because that just is the standard that we use that we can't. You could argue that maybe that was the rule back when, like, before we had computers and people wanted to let things simpler. You saw the difference in calculating the probability of binomial versus calculating the probability of geometric. I have a geometric. The binomial is a lot simpler, so you can argue that, well, the fluid density is right, and that's a fair point. But that's what I was getting at. I don't think I made it work that much, but I actually remember it so long. Any other questions? About class? Or general? Yeah.
On the exam, what percentages each, I guess what percentages unit 4, 3, 2, and
So I try to make it about 1/3 to, what is that? How do I do it? 1/3 to 1/2 new stuff, and 2/3 to 1/2 old stuff. So it sounds like that I'm really emphasizing the old stuff, and I kind of am. But given the old stuff is 3/4 of the class, the new stuff is 1/4 is disproportionately new stuff.
But it's typically about 1/3 new, 2/3 old. And you can look at a practice exam and you can get that impression too. Yeah. Everything will be mixed up. And you can see that if you pull up the practice exam, you can see what that distribution looks like. Yeah. Yeah.
One of the homework questions is, suppose you're hiring a new worker for your business and you like someone reliable.
Mm-hmm.
So suppose you administer a test to job seekers many other employers use to determine if applicants have the straight. The test is 90% sensitive and 95% specific. If 60 unreliable people apply and 20 reliable people apply, how many positive results do you know?
Mm-hmm.
Yeah, I didn't even know.
So, what did you say? We had 60 reliable people?
Unreliable.
60 unreliable people. Oh, there's a lot of, that's right, there's a lot of unreliable people in the world. And 20 reliable ones?
Yeah.
So which of these is a positive state and which is a negative state? Mm-hmm. I totally agree. And of course, that means the, I don't want to put plus to that, but this is, and then that means the unreliable is negative state. This is positive state. And this is the negative state. And what was our specificity and sensitivity again?
90% sensitive and 95% specific.
95% specific and 90% sensitive. So, that means, and we want to know how many positive results we got. So one way to get a positive result is to get a true positive. A true positive means that you correctly identified someone as reliable. Well, if someone walks in reliable, what percent of people will we correctly identify as reliable? 90%. So of these 20 people, we will correctly identify 90% of them as reliable. So 20 times 0.9 equals 18. The other way to get a positive result is to get a false positive. Oops. Sorry, false positive. False positive means we think they're reliable, but they are not. So is the test right or wrong? Is the test right or wrong? Wrong. The test is wrong. So if the test is wrong, that means it's not these values, it's 1 minus these values. Which one of these do we care about? Sensitivity or specificity?
For wrong?
Yeah. For not for wrong necessarily, but for false positives. Like if it's a false positive, are they actually reliable or not?
Oh, specificity.
Specificity, because they are not actually reliable. So in dealing with the unreliable people, the test was incorrect. So 1 minus this is 5%. 5% of these people we will call unreliable. Or 60 times 0.05. 60 times 0.05 is, of course, 3. Add them together, you will get 21 positive results. 3 false positives, 18 true positives. Any questions on that? No? Yes? 0.05 was 1 minus this, the specificity. So specificity is all about detecting. So let me go back. In order to get a false positive, you have to be dealing with someone who is unreliable and the test is wrong. That's a false positive. Right? They call them, you say that they're reliable, but they're not. Well, if we're dealing with the unreliable people, that means we're looking at specificity. Specificity is all about detecting the negative state. So, but the test is not correct. The test is incorrect. So this is specificity and sensitivity are both measuring the correctness of the test. So if it's incorrect, it'll be 1 minus this, which is 5%. 5% of these people will be false positives, or 3 false positives. Did I clear that up? Yes. Any questions?
Yeah.
Yeah, one more.
Suppose you
No one has any questions about this, though, right? Okay, great. All right. So what were you saying?
know, 600 die and coins.
Okay.
I got the first one, like just took it, but it says you'll get at least 1 heads.
Oh, so you will get. So let's see. When you flip 3 coins.
Yeah, once it's and you roll 600 die, makes a chance you'll get an even number, and you'll get at least 1 heads.
Okay, so a 6-sided die. And 3 coins. And an even number is what we're looking at. And 1 plus heads. Well, there's a lot of different ways to get 1 or more heads, right? You can get 1 heads on 1 die, you can get, 1 heads on, you get 1 head, and there's 3 different ways to get 1 head. Right, the first coin is a head, the rest of tails. The second coin is head, the rest of tails. The third coin is head, the rest of tails. And then you can also get 2 heads, and there's different ways to get 2 heads, and you get 3 heads. Oh god, that's hard. You know what we could do? What is the chance of getting no heads? What's the chance of getting no heads? Anyone?
1/2 times 1/2 times 1/2.
1/2 is 1/2. What does that represent, Michael?
I don't know.
It represents only tails, right? So, of course, it's 1/8. If there is a 1/8 chance of getting only tails, then that means there is a 7/8 chance of getting at least 1 head. Right? There's eight different things that can happen. One of them results in only tails. That means all the other ones will result in 1 heads or more. So that's the chance of getting only. That's the chance of this part, 1 or more heads. And what's the chance of getting an even number? 1/2, which equals 7/16. Okay. Fun stuff. Any other questions? Great. So if there are no more questions,
We actually got over one of those ones where it was like, actually, like specifically the one where it said if you're 99% specific and 95% sensitive, 2% of people use drugs, what's the probability?
the base of that one,
Yeah, what's the probability of them not using drugs if it's negative?
I actually have a question like that. We can go over that.
That's what we can do that here.
So what I do is, that'll be one of the questions we can cover. We can do that one pretty quickly. We'll do that first one out of the range. Before we do, does everyone have one of these? Good catch. I'm not going to throw that all the way over there.
There you go, okay, I will walk. Sorry, there we go. Good catch. Anything else? Plus the computer's good, worked out well?
Yeah.
I really should not know these. I will tell if you don't.
Anyone else? So how many of you have ever used one of these before?
No, you have Michael and a few of most people who have had them before in class. Those of you who don't know, these are response cards. I'm used to calling them clickers because I use a different version of them, but it's the basic idea. Is I will put a question on the board here, and it will be a multiple choice question, and we'll open up polling.
And then you can select, A, B, C, D. I can go all the way up. I don't think I've gone all the way up to J before. Oh, no, I think I have once. But you'll have many different options. You'll select one of them. And then it will show you a green light. If it all works, it should show you a green light.
I'm scared today that these run out of battery.
I don't know how to change the battery in them. I guess that little thing there, whatever. So it'll show you a green light, and that will say it's received it, right? The computer has received your answer, and it will add it to a tally. You won't see the tally until I've closed the polling, and it will show everything. Some people get a little confused, like what happens if I select A, and then I realize I want the answer to be B? If I select B, is that okay? Yeah. It knows, right? Every response card has an ID. You can see the number on the back. This one is 5CEA16. So it knows that you have selected B before you selected A, and it will move your result, your input from A to B. So don't worry about selecting more than one. Whatever your latest one is what it will read it as.
Also, don't be the person that points at the screen to make sure this is just a screen, just like back in here. Right? This is the recorder. So it really shouldn't matter. You can just point it anywhere, or read it as long as you're in the room. But if you really want to feel good, if you really want to make sure it gets it, point to that.
Don't point to this. All right, any questions about how this works? Great.
So to warm us up, I have some polling questions. This is a good reminder too that evaluations are available on Blackboard. A lot of you haven't done evaluations. I know a lot of you in this room have, but I'm going at like 50% chance for this class. So just a reminder, and for the other one too, if that's available for you, extra credit and all that. But this is a question that is not answered on the official evaluation, so this is my chance to ask you. As of course you are aware, my lecture notes are available on both my website and on Blackboard. I'm curious, because I have to maintain two different places. I'm always curious if people use both of them. So I'm wondering, do you only use my website to get lecture notes? Do you only use Blackboard? Do you use a mix of the two? Do you not access them at all? Did you not know they were available? I'm always very curious with the people who didn't know class notes were available. Go ahead and submit your answer. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Oh, so we got almost everyone. There's always that one person. Is yours not like making a little green light? Yes, I got it. Yeah, you got it. That's my mouth. Yeah, there you are. Okay, so it looks like, oh, interesting. There's always that one person who's like, I only use Blackboard. Why do most people use my website? I think most people at least.
It's easier to get in.
Easier to get on? You don't have to log in? But then why do people sometimes use Blackboard? It's so weird. Scratch the screen. It's because I'm already there. Yeah, that's true. The quizzes are that makes sense. That's right. Yeah, I can't put quizzes on my website. That won't work for all kinds of reasons. That's true. That's a good point. Have you actually watched these?
Yeah.
Yeah? Okay, that's good to know. That's one of the reasons why I'm recording this one too, so I thought it would be nice to review. And what I want to do is I want to post both reviews online so that you can watch the review that was for the other class. That would be, that's why I'm going to try to ask you different questions. Yeah. That's right. I mean, there's going to be some questions that are overlapping, obviously, these polling questions, and maybe one or two other questions. Like, they have also had that base one that you want, so we'll do that one again. But I'm going to try to mix it up some so that you can watch both of them this university. That's a good point. I should put the links to my website. I hadn't thought about that. All right, that's why I asked these questions. Another one. So, here's how we do this class. If this is Tuesday, and this is Wednesday, and this is Thursday, and the exam is here, your homework is due Wednesday at like midnight, which, because I want to give you multiple attempts, that means that I cannot do the constraints Blackboard. I cannot show you the answer key until after this due date, which gives you like literally hours, assuming you want to sleep, which you should, before the exam to look at the answer key. I just hate that. I hate that so much. I'm concerned, so I thought about moving it rather than the homework being here, which is option A, the homework be here, due Tuesday at midnight, which is option B. The problem with doing this, though, is that the material that we cover on Tuesday means you have to then complete the homework that night. So this would, if you do E, then that means you would have all Wednesday to look at the answer key and figure things out. But it also means that you have to then do it that night. So I'm curious, currently I obviously have the system where you do it on Wednesday to give you the most time, because I know people have issues completing things sometimes, work or whatever. But would you rather have it switched so that it's due 2 days before the exam, rather than the day before the exam? Okay. It's a little more mixed than last time, but still people tend to prefer E. Why is that? Why do people tend to want to go in that direction? Yeah.
You may have more temperature if you go arrows.
So it's that much more. So you don't mind that you'll have a smaller window to get it done. Okay. That's true. That's true. You'll have Wednesday asking questions. And as I'm thinking about it, sometimes the exam is on Tuesday. In which case, I should definitely move it back forward, like Monday night. Sunday night rather than Monday night. Okay, I'll do that next semester. You don't care now, but. Any questions on that? All right. Great. So let's actually get into some of the questions Tom might have for you. Let's start with a straightforward one. If a variable has a standard deviation of 0, what must be true? Is it A, the mean is also 0? Is it B, some values are negative and some values are positive? Is it C, all observations have the same value? Or is it D, it is impossible to have a standard deviation of 0? Okay, so it looks like we have, most people go out and see there's still a fair amount of disagreement. About half of you are in another direction. So why don't you take some time, try to find someone you disagree with and try to convince them that you're right. And this may or may not be the case. Sometimes people assume that the most popular answer is the right one. That may or may not be the case.
You are all alone in the corner. Are you going to talk to anyone? You're all alone. You should at least talk to each other. And there's a whole group over here you can talk to. They don't want to cross the aisle. Oh, you guys are just so far away. Did someone move closer to you? Oh my goodness. It's far. Your chair has wheels. Your chair has wheels. Look at them. They got a little group over there. That's what I want to see. That's great.
But they're not falling.
But like you get close to each other so you can talk. Yeah. Oh, goodness. And for the record, they are falling. It's your time. It's your time. I don't care. You don't want to talk to anyone? Try to figure it out what's going on. That's fine. It's not you.
That doesn't necessarily
Talking
Standard deviations.
Yeah. So just so you're aware, I reopened the polling. So if you've reached the consensus with your group, you can go ahead and resubmit, and then we'll see where we are.
That's true.
Did we reach the consensus? Okay, so in the interest of time, because we're about half hour to class, in the interest of time, if you could go ahead and resubmit.
By the way, the sign sheet's still around here somewhere. I don't know where it is. Oh, it's right there. So who signed it? All right. Yeah. You don't have to.
I was so like kids to millennials. All right, I'm going to close the polling in a few minutes. Not a few minutes, sorry, a few seconds. Yeah, thank you. Just take it, pass it around. I'm gonna close it in 3, 2, 1. I don't know why I'm looking at 13 rather than 15, but I know that's enough to know that time is too scarce. Let's wait. 14. Hey. So you know how I said thank you? You know how I said that just because it's a popular answer doesn't mean it's right? In this case, it is right. C is the right answer. Sometimes though it's literally happens, like it's like the most popular answer was also wrong, and then that people talk amongst themselves, they just gravitated toward the wrong answer. So like, let's go ahead, it's popular, so it's right. But in this case, C is correct. It is correct. Why does that make sense? Why does it make sense? Anyone? Because they got 70% of you know it's correct. So why? Yeah.
Is it standard deviation is 0, means there's no fluctuation from the mean.
Well,
So it doesn't,
yeah.
the mean doesn't necessarily have to be 0, but it's the same value.
Exactly. Exactly, right. If imagine a whole data set of nothing but x, where x is any number. It could be 9, could be 0, could be negative 45. That means that remember how standard deviation is calculated, the first thing you do is you take the difference between each observation and that mean. And if every observation is literally the same, then you're going to be getting 0 over and over and over and over again. Because anything x minus x is always going to be 0. Thus, the mean is 0, You're gonna add that up, add those zeros together n times, it's still 0, take the square, it's still 0, divide, it's still 0, whatever, right? Most of these are 0. So, exactly. All values are the same, C is the right answer. Any questions on that? Let's do this one. True or false? A mean is a weighted average but with equal weights. Okay, looks like we have some disagreement. It's time for you to try to find someone you disagree with and try to convince them that they're wrong.
I mean, it's so.
That's sort of.
I feel like that's like.
There's the decimal one where it's like. Is there?
I mean, it's weighted average.
I would put in like, yeah, but sometimes people work out something where you can like get partial credits. Like, I would like to do like, if it's a 1 scale, 1%, you give them this much. If it's 10%, you give them that much. There's like a website.
The weighted average. These fields of fractions.
I think using fractions too. Some stuff like, because some things you can figure out what it is. And then like, if you figure out what it is, you can use the fraction.
What's your basic fraction? Instead, you can have the basic fraction. They're typically really good.
Figure out what's going on. It's less than recording stuff now. My task will be writing this equation. Another practice exam. I have super because I teach macro so much. I'm able to generate enough material. So I need to because I teach so much. And now I don't have one. I only want this one kind of it takes a while to write all the practice exams. Answer keys and everything. I prioritize this class. Additional practice.
I remember you used to have the 2 practice exams. There's 2 questions on this 2 practice exams. There's always.
It was usually when I wanted to record. I wanted to record. I might choose one, maybe two.
There was always, I thought there was always one, that's literally exactly.
I try to do that less though.
All right, so go ahead and put in the responses, please.
Those in, 5, 4, 3, 2, 1. We spent a long time, we're gonna spend a long time discussing it, so yes.
I'm glad we got 200%, because clearly that is the right answer. That is absolutely the right answer. Why is that the right answer? Dead silence. Yes, Michael.
Because the mean, it always, you add up all the numbers and divide it by the n number of observations, while the weighted average is you multiply each observation by a certain percentage. And so, if the mean, on the mean, technically everything will have the same percentage, the same weight, and the weighted average, it'll have the percentages.
Exactly. So, in other words, I can make this, that would be the same as put that 1 over n and then distribute it. That's the same thing. That's exactly. You just multiply everything by that one same amount. So it ends up being the same. Any questions? Okay, super boring then. Great.
Let's do something more exciting. You know, I want to make sure we have enough time to do what we want to do, so let's do that one. Skip way ahead. Suppose 6% of employees have stolen a notable amount of money from their workplace. And also suppose you devise a test which is 80% sensitive and 90% specific. About what is the probability that an employee is stealing, assuming the test comes back negative. Is stealing, assuming the test comes back negative. In other words, you missed them. Of course, you can do this mentally.
do another one of these. I'm gonna give you lots of practice. So,
well, yeah, like, you know, you can send them off whatever. So you're gonna have to round it to something appropriate.
I remember people wouldn't give me like 8 decimal places. Like, hard to read. 3, 4 is like the maximum. I like to do 3 because, you know, 1.4% or 33.8%, like that translates really nicely. All right, in the interest of time, I'm going to close polling in 20 seconds. This is the question I gave the 9:30 class, and I want to have time to give you a different one, because I forgot I actually had 2 of these kind of questions on this, so I want to give you the other one as well, so that we have both of them in case that you guys get more practice in the 9:30 class can see the other one. So, close polling in 3, 2, 1. Okay, so we have a fair amount of disagreement. Why don't you take some time and try to find someone you disagree with and try to convince them that you were right. And I'm going to write some stuff on the board, make a guide, guide your conversation. What is the probability? Someone writes stealing? The probability of something like negative assuming that they're stealing, the probability of stealing the probability of something negative assuming that they're not stealing, and the probability they are not stealing, and the probability that they are stealing equals 0.06. The probability that they're not stealing equals 0.9. Result, assuming that they're stealing, being 2. And the probability that they are assuming they are not stealing is you reach consensus.
You want to stop the evaluation?
You can do either one. I don't care. I think motivation is because in that one you're calculating things you don't see.
I just did the process right. I just did
Based on the I'm going to reopen polling so you can resubmit since I know all of you are so confident. Yeah. Okay.
Assuming that it be that the probability is, and so then you kind of just assuming that the light do steal and it's negative still, because like kind of
Well, this is assuming they do something. Yeah. So that's what I did over there as well. So
then I just almost switching these. This is assuming that all roads steal. Like, what's the probability? Assuming that what's the probability? Assuming they are stealing. That's it. So now.
So that's literally how I think about it when I do this. You just swap it around. It's really smart. Like you really appreciate it. Like that's really clever. Because the first time you see this equation, you're like want to kill yourself. But then you work with it more and more. You realize it's actually really elegant. It's really insightful, and it's a very simple thing to memorize.
That's when you first explained it, I really understood. Really understood.
Yeah.
Not the first.
You think it's more like you thought you understand the first time, and now you're getting used to it. You see it in all the different ways it pop up, and now you're internalizing it. It's how I think about it.
All right, we have about half of you submitted, so if you can go ahead and finish that off, and the other half of you submit now, we'll talk about it. So I want to do another one of these to give you that additional practice. I've just been doing mostly 3, 2, 1. We all got things to do. Seriously? Fine, fine. 3, 2, 1. I'm doing that. Okay, so
Wildly different opinions. So I've set this up here to guide our conversation. This is what we're after. What is the probability that someone is stealing, assuming the test came back negative? And then I just applied Bayes' theorem. And so I just, the negative sign is the B, the S is the A, you would just substitute it. Now let's do the component parts. This one is really simple. What's the probability of them stealing? Well, that's right there in the question, 6%. So then what's the probability that they don't steal? What's this? 94%, right? Obviously they either steal or they don't steal. This one is the hard part. What is the probability of getting a negative result, assuming that they steal? Is that result correct or incorrect? Is that result correct or incorrect? It is incorrect. I feel like I should turn on the lights so people can see what I'm doing. It is incorrect, which means we are not looking at 80% or the 90%, because those say that the test is correct. Right? Those are measures of accuracy. We want to go the other direction. We want to look at 20% and 10%. The question is, should we look at the 20% or the 10%? So we ask ourselves, what is this concerning? Is this concerning people in the positive state? Or is this concerning people in the negative state? Does this concern people who are stealing, that's the positive state, or people who are not stealing, negative state?
Stealing.
This is stealing. Why?
Because stealing, you said they are, they do steal.
He said, we miss it. I think it's absolutely right. We miss it. That's where wrong is. If it's negative and it's wrong, it is a false negative. And it's going to concern the people with the positive state. So therefore, 1 minus the sensitivity. The sensitivity concerns positive state. So that's point 2. And finally, this is the chance the test is right, assuming the person is stealing, which is just sensitivity. And we need to shut the door, simply doing the emergency right now. Then with that in mind, we just put the numbers in. That's chance of the stealing, so that's going to be 0.2, and that's going to be 0.06. That's right there. And then we're going to do the same thing over here. And then we're going to do that part right there, which is 0.2, 0.94. And when you do all that math, you should get 0.014, which is something, of course, you can do in your head. I'm kidding. Any questions? This ends up being, by the way, if you want the intermediary step, this is 0.012, and that is, of course, 0.012 plus, I believe that's 0.858, I want to say.
No, it's 846.
Eight. Oh, the bottom is, yeah, you're right. 846, and the bottom is, I was just so far ahead. 858. And now, oops, I should circle that. That's not the right answer. 0.012. And you can just sort of, even if you got to this stage, you can just sort of look at this and be like, granted, I have a none of the above answer, but you can just sort of look at this and like, well, that's going to be a little bit more than 0.012 because it's 158, and it turns out it's actually there. That. Any questions?
Could you do this on a tree diagram too?
Yeah, you can do it on tree diagram. Oh, you want me to do it now? Oh. Tell you what, why don't we do another one, and that one I'll do on tree diagrams. Here's another one. And I made a slight error here. What is it going to do? That shouldn't say accurate, that should say specific. So consider a test to determine if someone has a disease and 1% of people have. The test is 95% sensitive, 98% specific. Let's make that specific. What is the probability of having the disease assuming the test came back positive? Probability of having the disease is 0.01. Probability that you don't have the that. And sensitivity is 95%. So you try to do it on your own quietly, so that as the exam will not be group work.
So this shouldn't be either. You're gonna have a test online once, once we submit it and we see how people do. Thinking on their own. One sign.
Is this yeah, this night. I mean, assuming the yes. Can you show the formula? Oh yeah, just put the formula. Yeah, I didn't get one of that. Then you got it.
Ideally, to
Make it clear what we're talking about. He doesn't understand. I don't see what's wrong with this here.
I opened the border. Yeah, okay. That's all. So, that's yeah, it's like at the top of the end, obviously.
So we're have about 15 minutes of class left. So ideally we'd be able to do this one and another one, which was fine. You might want to start soon. Alright, I want to close the initial polling. I see people talking amongst themselves. I assume we will submit it. So since people seem to be eager to talk, let's close the polling and see how people are. 5, 4, 3, 2, 1. The suspense is killing me. Okay, so it looks like we have a fair amount of disagreement. So why don't you try to find someone you disagree with and try to convince them that you are right.
I'm going to move this up. Specificity is 98.
Once you like fill in what you can figure out, you're trying to fill in if I assuming the process. So probably that's your denominator. And then this part right here is the same. So you just always like put one on the side so that this is so the probability so it's going to have and there's just more stuff that I see in the past to go
So I've reopened polling for people who want to. I don't remember what the original distribution was. No, I don't remember what the original people said. I just remember people disagreed. Making sure you dealt with that. Any questions? Any questions over here? Nope. So we only have 6, 8, we are 8 of you. I would like to try to do another question, so wrap it up. We'll have some time for the talk. Discuss. So you're like, so when you put it there, so yeah, you do like, you actually have to do that. These are the ways to get a positive result. What is that second one? 9.971. What is it? 0.995. Oh, yeah. So why is it, what is that 97 equal to represent?
Probably that they don't have the disease.
So look at that as a list. Following that. So this is the they don't have disease. That is what? The specificity. So in other words, it's actually correct. So what is the test conduct? No. The chance that we get this result. What is it? So you don't have the disease. The test is correct. What's the test say? Yeah, what's the test say? So the value is negative. Right. What is I asking you? Assuming the test comes back positive. Why is this part of your denominator? Okay, in the interest of just only have a few minutes left, so in the interest of time, if you can go ahead and submit. We might not have quite time for another question, but I'm going to close it in 3, 2, 1, 1/2, 1/4, 28, 168, 137, 164, 121. Okay, so it looks like we have a fair amount of student that sees the right answer. I think that's right. That's totally right. Let's talk about why. So like you wanted to do this version. Okay, so let's first appreciate how I set this up. This is the chance people have the disease, this is the chance people don't have the disease. Everyone follow that? So then I said, assuming that they have the disease, right, and now that's what's going to be in both these cases, assuming they have the disease, what's the chance the test comes back positive? What's the chance the test comes back negative? And I think this was 0.95. Why is that 0.95?
Because that's the positive state.
Mm-hmm. That's the positive state, and that's the test being correct.
Yeah.
Right? And that would be sensitivity.
Why did I make this 0.05? And then I actually hit the light. I should probably hit the light. Why is that 0.05?
1 minus.
Exactly. Right? Because the test is wrong. The test is incorrect. You say it came back negative, but you do have the disease. That's incorrect. And because you have the disease, we look at sensitivity. Because it is wrong, we take 1 minus this value, so 0.05. Here I have, so now I'm looking at the don't have the disease part. Is the test correct here? Say yes, Ike. Why?
Yes, because it's correctly predicting that you don't have the negative state. Having the disease.
Exactly. The test came back negative, and the test is correct. You don't have the disease. And since it's correct, we just look at the raw value. Since you don't have the disease, that's the assumption. And we look at specificity, the negative state, 0.98. And this is going to be the same story as before. In this version, the test is wrong. The test is wrong, 1 minus it, and therefore 0.02. We're good so far? So this one, so we're wondering the chance the test comes back positive. Which of these, 1, 2, 3, and 4, which of these are positive results?
1 and 4.
1 and 4. So we don't care about this one, and we don't care about this one. We care about this one, which is a positive result, and this one, which is a positive result. We should, even if we want to make it symmetric, we call this PD. So note that if we were to do Bayes' theorem, I don't even need this anymore. It would be, what is the chance that someone has a disease, assuming the test comes back positive, is the chance that the test comes back positive, assuming they have the disease, on the chance they have the disease, over P plus, and then given D, P D plus P positive, given not D, times P not D. This top part is where?
Oh, it's the 1.
Exactly, right here. So you would take those two together, 0.0095. That's that right there. And that's also this right here, too. And this is the other part. Positive results, assuming they don't have the disease. Positive results, assuming they don't have the disease. Positive probability of not having the disease. Probability of not having the disease. That ends up being 0.0198. Right. It's 0.198, right? I just want to make sure that I did that correct mathematically. So if it was 2, it's right, good. And then when you add these, and then when you do some math, this becomes 0.0095 all over 0. I don't want to make a mistake. So 293. And that's what I have to do. 293. 0293. And that becomes the answer is 32.4% chance. Any questions? Easy peasy? Yeah, simple. So again, I don't care which way you do it, because you know you're doing them the same way. Right? It's exactly the same thing. You just figure out where the positive results are, where the negative results are, if that's what you care about. Or you can do it this way. Either way works.
So it's now 12:15. So we're actually out of time. That concludes statistics for BSA 8210. I hope you had a really great time. Those of you who are still here. And, of course, the point of this class is to arm you with the basic tools of statistics to show you how, not only like how hard statistics is, but also how incredibly useful it is. Right? This is a world where data is becoming a lot more easily attainable and easy to get a hold of, but information is not so easy to get a hold of. So much of this class is about taking that data, that raw data, turning it into information, turning it into something useful. As you can tell, it is difficult. There's a lot we didn't talk about, but this hopefully gives you a good enough grounding to what it means to be smart and literate in this world. And I hope you had a really great time. We'll see you next week. Oh yeah, make sure to turn those clickers back in. And thank you. This concludes the course.